Okay, so in part 2 here, lesson 4, I'm just going to bring up my tools, and we're looking at example 5 here. Solve and verify. Solve the equation log x squared minus 3 log x equals 10. And what we can do here is, this almost looks like a quadratic, and but notice this 2 here can come up and come in front, giving us 2 log x minus 3 log x equal to 10. So 2 minus 3 is just negative 1 log x equal to 10. Multiplying both sides by negative 1, we get log x equals negative 10. This is really base 10, so we can bring the x down and bring the 10 over, bump the 10 up, and we get this scenario here where x is really 10 to the negative 10 or 1 over 10 to the positive 10. Make sure you verify this. It's a positive number. When you log it, squaring it, that's fine. So that works. Explain why the equation, this equation here, which is log x all squared, this is different, it's just the x being squared here, why this cannot be solved using the laws of logarithms. Now, as I was mentioning earlier, this looks like a quadratic, but in fact it's not. However, this is, because the log of x is being squared, the whole log x is being squared. Here we have a multiple of log x and a number involved. Now, this question can be solved using quadratics, but it's saying why can it not be solved using the laws of logs? Well, one reason is because this does not equal this, and therefore it cannot be simplified simply by bringing the 2 to the front. So, solve the equation using the following steps. Basically it says replace log x by a new variable a. If we do that, we can see that it is turning into a quadratic. We've just said let a equal log x. And then factoring this, bringing the 10 over to the other side and factoring it, we can see that a would equal negative 2 or plus 10. Which really means that a was log x. So log x equals negative 2 or it equals positive 5. Alright, so we can solve this and solve these, both of these independently. Basically, if we do drop swing bump, we'll get x equals 10 to the negative 2, or 1 over 100. And here it would be x equals 10 to the 5, or 100,000. Check both these in the original, which is up here. X, we can log a positive number, they're both positive, and here as well. So both of them work, so we have both solutions in this particular case. Okay, just finishing this example off, a student is solving this particular equation. Our work is shown, and we can see that log x is being squared. This is really negative 3 log x when we bring the 3 to the front, and it equals 0. So if we replace, one way to do it is just replace log x by a, and we get the following. Now, look what's happened here. This is an error. If you check, log x is a, fair enough, and it's squared. But this is not log x being cubed. It's x being cubed. So this is wrong. Okay? This is really a to the 3 is really log x all raised to the exponent 3, as long as we're making this a here. Over here it says let a, yeah, that's what's happened. So if we continue with this scenario, it tells us here that, continue with this scenario, sorry, we can factor out a squared, given this. So either a equals 0, or a must be 1. So log x is 0 or log x is 1. What does that mean? Doing a drop swing bump, x equals 10 to the 0 or 1. or x equals, in this case, 10. Using both these values, you can see that it would be okay to log these two values. They're both positive. But this log x cubed is not equal to a cubed. That's the trouble. And so this is really a quadratic. It should be written, just pause for a sec. It should really be written, we should go from here down to here, where really we have the 3 in front. So it should be negative 3 log x, or negative 3a in this case, equal to 0. Now we can factor out a, leaving a in bracket a minus 3 equal to 0, so either a is 0 or a is 3. And again, can we use both these values? Can we log 0? No, cannot log 0. And here, again, we can't use 0. Can we use 3? Yes, log of 3 is fine, and so it's fine here too. So there is only one. Oh, sorry, my beg your pardon. This is 10 to the 0. I forgot to solve. Just ignore what I just said. Log x is 0. So that means x is drop swing bump 10 to the 0, or 1. And log x is 3. So drop swing bump x is 10 to the 3. So both these values are positive. There's no trouble fitting them in. And you can check if you like to make sure that if x is 1, log 1 is 0, 0 squared is 0, and 0 minus. Putting 1 in here, again, log of 1 cubed is still 0, so yes, that's true. And you can check with 1,000 if it works as well in the case. So, there are two answers to this. So there's an error in the student's work because x equals 10 does not satisfy the original equation. This value here would not have satisfied this. So something is not working. Alright, so please do all of the questions associated with the assignment, and we'll see you in class.